Hello everybody, and welcome to the latest in our Coda series of webinars. My name is Francis Norman. I'm the CEO and Managing Director with the Centre of Decommissioning, and we're absolutely delighted to bring this series of webinars to all of you. So for today, we've got something really different, very interesting, very exciting, and some, we talk about cutting edge technology in the industry. It doesn't get much more cutting edge than dealing with services coming from space. So today we've got Børre Pedersen from Kongsberg Satellite Services to talk to us about how they use their technologies to support decommissioning activities. So a little bit about Børre before I hand over to him. So Børre currently holds the position as Sales Director for Earth Observation for the Asia Pacific region from Kongsberg, from KSAT. In his current role at the Earth Observation Department, Børre works with his colleagues in providing near real-time satellite-based monitoring to help partners with challenges related to oil spills and better vessel detection services for decommissioning. As is normal with webinars, if you have any questions that you'd like raised, if you could put them into the Q&A box, and as Børre finishes his presentation, we'll try to get through as many of those questions as we can. So, yep, keep the questions coming as you go. And with no further ado, I will hand over now to Børre to give us his presentation.
Well, thanks, Francis, for the introduction, and we're delighted to join CODA. And we are not operating oil or building rigs, but we're building infrastructure to help the industry monitor for spills and the like. And I'm here at KSAT we are working with the European Space Agency for a couple of years to as a start and to promote how satellites can be used for the decom industry. So with that, I will go and introduce KSAT. So we connect space and Earth. We are the world leading provider of ground network services and Earth observation services. Headquartered in Tromsø, in northern part of Norway, 350 and some employees. We have offices in Svalbard, in Oslo, Stockholm, and in Colorado. We're a medium plus size company. The revenue is about 220 million Australian dollars for those of you in Australia. For those of you on other locations, the conversion rate can be found on Google. A little bit of KSAT. We are here to stay. As you can see from the ownership, we are partly owned by the government through the Space Norway, and the other 50% is owned by the biggest industry high-tech group in Norway called Kongsberg. So that means that our ownership is very stable and solid. Kongsberg has been around since Kongsberg Group has been around since 1814. So we've been around for a while. So we connect space and Earth, and how do we do that? I thought I could introduce a little bit on that. Some of you in the audience is probably from the oil industry, so we're kind of similar to you guys. We start out to find a nice place that is suited for the job. Our job is to receive satellite data, so we search around the globe, and in '97 we went all the way up to the North Pole, starting to build a Svalbard station, which is a perfect location for satellites. And then we need to find the right people. So on the left side, that's the first crew at what's now KSAT. It's back in 1967. We have expanded since. We dropped the white colors and put on some working gear and flying around the world to install the antennas. So found the right place. We build the antenna. As you can see, we have drilling equipment as you have. Our tools are a bit smaller than yours, but it's doing the same thing. We're drilling into the bedrock to have a solid foundation for the antennas. And then we complete the job and voila, here we go. This is a picture from Antarctica. You see the man standing on top of the radome there, just to give you an illustration of the size. So this concludes, I guess, just to show you that we do install and find the right places, and we're having great fun. And then once we do one antenna, we repeat. So the map you see here is where we currently are located with our antennas. It's in 27 locations around the world, all owned and operated by KSAT for the purpose of providing satellite-based information back to the customers and satellite owners. Everything is done in real time. This is why we have so many antennas, is to reduce the latency on the data. So building all these antennas, handling them, we have three. So what do we do with them? We keep building antennas. The Svalbard station, as you see on the left, have now a little more than 150 antennas. I am working in the Earth observation group, where we provide value-added information to customers like the oil industry and for environmental purposes, a little bit into the defense, and we don't. So we serve the customers as they come along, but oil industry is one of the main clients for us in the Earth observation department. So it's run from the headquarters in Tromsø, close to the North Pole, well inside of the Arctic Circle, 69 degrees north, and yeah, just some more details about the Earth observation services. As you do, we have a strong focus on the maritime, vessel detection, ice monitoring, oil spills, fisheries, greenhouse gas is coming up. There's actually a lot of satellites now flying around where we also receive them on our network, providing basically methane detection to clients that is following the COP26, 27 suggestions. I just need to share this again. Svalbard, our main ground station. I've been there, worked for 5 years, survived, and then moved down to Tromsø, where I've been in the company for in total more than 25 years. So, and then I have a small illustration here, just to give you a little bit of idea on how is the satellites working and how can we deliver the information to you as quickly as possible. So this, if you pay attention to what's going on the screen when I hit the play button, you will see that the satellite is coming over. In this particular case, it's a demo over India, but the concept will work well in Australia and in any other place. So as you can see, there's a scan on the east coast of India. The satellite will carry the data up to the Svalbard station, where it will start feeding the antenna with the image that it took down in India, and then further into the processing chain that we have in Tromsø. So in Tromsø, where we have 24/7 operations, so we for those of you that have signed up as a customer to KSAT, you know that we're always on the duty. So if you need to talk to someone in the middle of the night, feel free to call our ops team if you have any operational questions. As you can see, we have here what we call the SAR. It's radar satellites, and that is our main focus. We have processing capacity for 15 different SAR satellites. It's not search and rescue, it's radar satellites. So in addition to a few optical satellites to enhance the product that we deliver to the industry. So yeah, just to name these satellites, it's all the commercial and a few governmental or agency-owned satellites. But we do that because we have customers worldwide, and there is a lot of different weather. The radar satellite will penetrate clouds, and it will operate and give us and you the information we need, not depending on the clouds or if it's rainy. So if it's cloudy, you cannot hide from the satellites, and they will see what you are doing down, or what we are doing down here on Mother Earth. So the satellite will see the oil spill, and also it will pick out the wind information, which is critical when you have an oil spill coming up, because the wind will then give us the information we need to provide you a drift model. If an oil spill occurs, we will use the wind in addition to other information to tell you where is the oil going to go. So this image here, as you can see, this is to illustrate why we are using radar satellites. On the left side, you will see a radar image where we have our algorithms have identified an oil spill on water. And the picture to the right is taken more or less at the same time, a normal optical satellite. We don't see anything because of the clouds. So it's a perfect illustration just to tell you why our focus in the near real-time chain is based on radar satellites. So a year in KSAT. So we deliver a little more than 70,000 scenes of oil spill, not oil spill, but we monitor 70,000 different locations. We count roughly 10,000 oil detections year round and more than 5 million vessel detections. So we do operate more or less globally, and therefore we can also have a high number of scenes, oil spill detections and vessel detections, all operated from or delivered from the system through our operation center in Tromsø. So satellites versus vessels. Can you use airplanes? Yes, and yes, and yes. But this illustrates quite nicely, I think, why satellites are such a great assets for the monitoring of maritime areas. It will be the same on land, but as you can see, a vessel will cover roughly, can cover 10 or 1,000 square kilometers per hour. An aircraft is 35,000, and a satellite will cover or can cover 4 million square kilometers per hour. The satellite will do that with a fraction of the cost and no pollution from that. So like in Norway, we monitor all the rigs every day. It turned out to be the most cost-efficient solution to meet the government requirements in Norway. Going into the details about the decom. So here is the full picture of for decom as seen from us in the space industry and how we use the satellite-based sensors. So the decom, we do 24/7 support in near real time with oil spill detection. We have done that for a little more than 20 years. So, and using all the satellites as you saw on the previous slides. And when we see an oil spill, we can actually tell you a lot of information about it, like the relative thickness, and we will also supply you or provide you with a drift model where we tell you details about where we think the oil is moving towards. The same with the vessel detection. We have done vessel detections for many years. It's used for fishing activities, but also to provide for oil tankers. So any vessels, we can see small vessels, but we normally keep an eye on the vessels on 10 meters and above. Then the greenhouse emissions, which is now coming to be or has become a very important thing to monitor for all operators. And then we can do the with the KSAT, we can do the emission rate per hour, and we'll give you a location and quantity of if you have any emissions. So it could be, it's very good, for example, when you have oil fields, and to do how much methane do we emit today. So that's also a daily coverage, more or less. So it's a nice add-on to the environmental monitoring and the things like that. In addition to that, we can from using the satellites, we can have a look at debris and water quality. Debris meaning things floating around in the ocean, and that could harm you if you are doing critical maneuvers in the decom phase on the rigs. So a little more details here. Oil spill monitoring. And as you can see, we don't see oil spills every day, but this is one of the important factors, is actually to demonstrate that you do operate the clean sea. There is no leakage from rigs or the floating production facilities. And we can also identify natural seeps, because if it's coming out from Mother Earth on its own, then it's not the operator's fault, but it can be used as a document to show to the authorities or regulators that this oil is not coming from me, it's coming from down below. And the other thing about the daily monitoring is that you can do a rapid spill identification and also the response, because if we see an oil spill, we will report it to either the operators or the regulators or to someone that is in charge of that. In Norway, we have NOFO, which is the Norwegian. It's an organization that it's from government that is in charge of keeping an eye on all the rigs for oil spills and pollutions from the rigs every day. So we report to them, and then there's a mechanism behind that that will start the process in case there is a spill. So when you do in a decom phase, you will have vessel monitoring, and traffic information can be critical for you. If you are on a critical maneuver and you want to have a satellite view of any vessel traffic coming into your area that could interfere with your operation. So using satellites for that purpose, we can see big and small boats. And is it important? Well, it can be, because with the satellite, you can see areas, say, with smaller boats, area of 100 times 100 kilometers. So you will be notified early on when it comes to the vessels in the near vicinity of your operation. Yeah, so we talked a little bit about I talked about the methane emission. As I said, satellites are coming to help you to do the identification of your own or other emission sources. It's proven by case studies to be a very accurate emission rate. As I said, you do it on the kilos per hour rate, so it's and the report will come out identifying the locations. So it's now starting to be used across the industry, and it's part of the ESG for a lot of the companies now. So debris and water quality. As I said, if you have something floating coming in to disturb you in a decom process, then having satellites to help you monitor the area around you can be critical, and it is something that we can look at either far away or getting in closer to the rig. But what the satellites can do is to give you the information in near real time. So if there is anything coming near to you, being vessels, being floating steel containers, you can be notified from KSAT using different type of satellites. On the water quality, there are some clever people that have designed sensors that can do water quality, and the concentration of, as you can see, different type of water. I honestly, I don't really know what kind of water quality it's mentioned here, but trust me, the scientists have found a way to do it, and we can do it by the satellite. So we will take in the satellite data, we will do the proper processing, and then we can send you the data and give you the information that you need in case you have a decommissioning that is leaking something. So after the decom, after you have, so in case there is an oil rig that you have decommissioned, you have plugged the hole and you're good to go. Then one thing with satellites is that you can actually do regular monitoring of that plugging in the years after or months after you have completed it. It's a very cost-efficient way of doing it, because you don't need to send out people, no vessels, no aircraft. We can order satellites to keep an eye on that rig, or that the old well for as long as you want. But the thing is that with the using of the satellites, you will get the report from your own old well sent to your email account or into a GIS system, so that you can prove to yourself and to the regulators, authorities, that yes, I have done a successful plugging of the old well. So I'm sure that this is a successful decommissioning process, and I think it's probably very interesting if you have any natural seeps nearby where you had your rig, because you can keep an eye on both and tell them that this is the natural seep, and here it's my old well. There is nothing coming out from that. So it's just to have the records of what's going on where you have where you used to operate and have the oil rig installed. So just a quick illustration of the operational service. So we have the area of interest, or what you call the decommissioning assets, being windmills or whatever, oil rigs. We will work together with you when we do all the satellite parts. Keep an eye on as often as you want. It could be once or twice per day. Give you the reporting. Normally it's or we will give it to you in maximum 2 hours after the satellite has flown over the assets, and then we will send out the report in any form and format. It could be by email, by FTP, or into API-based reporting. So it's a fairly easy process where where you get the information to you in a very easy to read and understandable way. So yeah, as I said to start with, we know what it takes to deliver the reliable operational end-to-end service. We've been doing this for 30 years, and being part of Kongsberg, we know that we are here to stay. So it's as long as you have oil rigs, we can help you monitor both the normal operations and when you come into the decom phase. Happy to help you monitor the assets with satellites. I think that concludes my presentation. So I'll hand it over to Pavel or Francis to see if there's any questions or remarks from the audience.
Oh, that's been absolutely brilliant. Thank you very much, Børre. It's way more comprehensive, and you do an awful lot that I sort of had a sense of some of the things that you were doing, but to see it all laid out like that's been really, really interesting. Thank you. While everybody ponders any questions they may have, and if you do have them, please slip them into the Q&A question box, and I'll ask them to Børre. I've got a couple of questions, and you may have covered some of this already as you on your way through, but just questions that I thought would be that I'm particularly interested in. What kinds of clients do you work with? You mentioned government regulators and you mentioned the operators, but is there a particular sort of way that your client relationships and just the different clients that you work, and how do you sort of report what to who?
Yeah. That's a good question. So we have I would say a combination of customers. Some of them will be like the NOFO, where we have it's a part of the Norwegian regulation that NOFO keeps an eye on all the rigs, but in other parts of the world, we have contracts directly with the owners of the different oil rigs. So there could be any of the private companies that is coming up and saying, we have a lot of rigs and we would like you to keep an eye on everything every day, because if you have a radar around a platform, you will see a little bit. I mean, it's limited where and how far you see. With a satellite view, we can cover all the rigs in one area, and if it's a single rig, then we will see all around it. And the reporting is done easily. It's like a PDF and with the geolocation, what we see, if it's we can do identification if it's coming from a ship. So the information is based on our 20 plus years of experience. So we have tuned the reporting according to the customers worldwide. So it's yeah, I guess if that answers your question, I hope.
No, that was good. Thank you. So we've had a question come in from Ty. Says, in terms of oil spill detection capability, can you let us know how sensitive it is, i.e. what concentration can the satellites detect down to?
Yes, I can, because any oil on the water will spread out and be like a film on top of the sea surface. So what we say is, or what we guarantee is that anything from 40 liters and above is detectable by the satellites. We have seen smaller amounts, but I'm not allowed to say that because our technical team will come after me. But so from a point of view, we say 40 liters and more will be detected from the satellites.
Sorry, could you just say that number again? It just broke up a little bit as you were actually saying the number.
Okay, yeah, no, it's 40 liters. So that's the minimum amount, and then going up to massive blowouts, of course. But so it starts from 40.
That's a pretty small number. That's very impressive. Yeah.
Yeah, it is. And when you do, so when you do the daily monitoring, even if you have a small leak on the rig, I mean, it doesn't have to be a major accident, but a small leak, doing the daily monitoring means that we can see it, even if the operators cannot or haven't discovered it yet. But we can tell them that, hey, guy, you're leaking a little bit, and then they can go and fix it before it comes in to become an accident or a massive blowout.
Very good. So I've got another question now from Roy. Could you explain what the coverage is down in Australia, Indian Ocean region, and how often the satellites fly over?
I can show it. I don't have it here, but let me go back to yeah. I can give you this slide here. So this is from the northern, the coast of Norway. So in the Indian Ocean and in Australia. So the satellites will fly around the Earth, as you can see from this video here, where it's coming over India. So it will come over India. The SAR satellites will operate in the morning and in the afternoon. So it flies around the world and takes around 100 minutes for one full orbit around the Earth. And as the Earth rotates underneath us, the satellite will cover the entire globe every day. And with our technology and all the antennas that we have, we can cover with 95% accuracy, I would say, everything every morning and every afternoon. So Australia, yes. India, yes. And there are some places it's on equator that is will have one day. I say 1 out of 15 days will not be covered by the satellites because of the area when the instrument is looking, the rotation of the Earth underneath will kind of tweak it a little bit. But daily monitoring everywhere as a rule of thumb.
That's very good. Yeah, you don't. I mean, the satellites, I guess, just keep moving around, don't they? And as you say, the Earth moves around underneath them. So how many satellites do you have? You did cover this in one of your earlier slides. So, and please don't go back to the slide. You don't need to. But just how many satellites do you have use of?
Oh yeah, with the radar satellites that we use in the oil industry and the decom, it's 15, or it's coming up to, well, I think it's 16 now, 16 different satellites. So that's why I can say that we do cover every part of the world as a rule of thumb every day. And then we put on optical satellite as well. When we see an oil spill, we can use satellites, and then we can tell you more about the oil spill itself, because then we can use normal imaging and have the bone code to tell you the color and give you more precise information about the oil spill. But in total, I would say we're using 16 SAR plus 6-7 optical, so it's more than 20 satellites that we are using operationally every day.
That's that's a lot. That's a lot of satellites, really. Well, it seems a lot to me anyway, as a non-satellite person. That seems like a lot of satellites.
Yeah, it is.
One more question from me, and please, if anyone in the audience has any questions they'd like to get off the chest, please do put them into the Q&A. Do you keep any historical data from these as well, or is it that you do it, you get it, you process it, you pass it along, and then you just keep looking? Do you know? I guess where I'm coming from for this is, if someone wanted to go back across maybe where they haven't drilled yet, just to see if there's some historical seepage, for instance, in an area where they're thinking of going, is that something that they would be able to do, assuming it's in an area that you've already been monitoring, presumably?
Yeah, we keep the data, and so if we have monitored one area, the data will be in our archive. And if it's a new area for us where we haven't been, we will go back into the old closet and in the old floppy disk to the satellite owners to look for archive data and see if they have anything. But we do, so seepage, for example. So if you have a new area and you want to see what is it looking like, what we do then is we can go into the archive, look for, do we have any records? If not, we can do a monitoring of the area over the time period of anything from a month to a year, so that we will give you a record of how is it look. Is it natural seeps here or not? Because if it is seep, we will see it from the satellite. Yeah, that sounds like something that would be very useful from a historical perspective for people going in, that they'd know if there was any issues there from the past. Look, there's been no more questions come in.
Oh, I say that, and it looks like we may just have got another one here. Here we go. Oh, this is a cracker. Were you able to provide any information for the MH370 investigation? So this was the Malaysian airliner that went missing. Did you have any involvement in any of that?
No, it was because it was too hard to look for tiny little parts, and that will be for the satellite owners themselves to program the satellite, because for us, being the man in the middle, we would need to buy information to and process to look for something, and it's a big ocean, so it's like we it wasn't for us to do that, but I know that the owners of satellites did look for it. But we have just to give you an illustration of other things, we have supported the search for submarines, and then because if it's a normal submarine, when if it goes down and collapses, it will leak oil, and then we could actually use oil spill detection to find submarines. It's not a normal way of thinking of oil spills, but it has actually happened. So it's when you do that, it feels like satellites can also be very useful to assist in that.
You just got to find more uses for it, eh? Just different things that come up, different problems. So yeah, look, that's been absolutely fascinating, Børre. Thank you so much for sharing all that information with us. For those online who are watching this, we will put a recording of this up on our platform in the not too distant future. Usually takes a couple of days to just to edit it down and put it up there. I noticed that you did have your contact details on the slide that you had up for a while at the end, but if you just want to pop through to that one quickly before we say goodbye, so if anybody does need to or feels inspired to get a hold of you after this. But this has been absolutely fascinating and so interesting just to think about how we could use an unusual, maybe a different technology to help us with some of the challenges we've got in the industry. So look, thank you so much. Have a brilliant weekend. You're up in Jakarta at the moment, I understand. So yeah, try not to get too hot out in the great outdoors there. Little different from Svalbard behind you on the picture there. Again, look, thank you so much, and thank you everybody for dialing in for this. It's been super. Thank you.
Yeah, thanks, Francis. Have a good weekend, everyone.